Welcome to the next phase of our 555 timer breakdown. Today we are going to look at the Astable mode of operation. The 555 timer is an incredibly versatile and popular integrated circuit, and the Astable mode is one of its most fundamental configurations. In this mode, the 555 timer acts as a free-running oscillator. This means it generates a continuous, unstable signal that automatically switches between a high and a low state without any external trigger. This constant switching makes it perfect for creating a square wave, which can be used for things like a blinking light or a clock signal. Let us look at the Astable circuit and its operation. The Astable circuit is made up of the timer IC, 2 resistor, and capacitor. The core of how this circuit works lies in the continuous charging and discharging of the external capacitor C1. The 555 timer's internal components constantly monitor the voltage across this capacitor and control the output based on what they sense. Let's walk through the process. The charging phase. First, the output goes high. This happens when the capacitor C1 voltage drops below 1/3 VCC. The timer's internal trigger then flips a switch, turning the output on. At the same time, the discharge pin, which is pin 7, turns off, acting like an open circuit. With that path closed, the capacitor begins to charge. It draws current from the supply voltage through both resistors, RA and RB. This charging phase continues until the voltage across the capacitor reaches 2/3 VCC. The discharging phase. When the capacitor C1 voltage hits that 2/3 mark, an internal threshold comparator flips the switch again. The output goes low. The discharge pin turns on, connecting the capacitor directly to ground. The capacitor now begins to discharge, but only through resistor RB and the discharge pin to ground. Notice that resistor RA is bypassed during this phase. The discharging continues until the voltage across the capacitor drops back down to 1/3 VCC, at which point the cycle repeats itself. This continuous cycle of charging and discharging is what creates the free-running square wave at the output pin. Key formulas you should know. The on-time TH of the timer is obtained when the capacitor is charging. The time on is 0.693 multiplied by R1 plus R2 multiplied by the capacitance of the capacitor. The off-time TL is obtained when the capacitor is discharging. The time off is 0.693 multiplied by R2 multiplied by the capacitance of the capacitor. The total duration T is the sum of the on-time and the off-time. Now what if you want specific duty cycle? For example, you want to tune on and LED for 30% duty cycle and turn it off for the remaining 70% repeatedly. In the next video, we will look at the duty cycle adjustment in Astable mode. If you found this helpful, don't forget to like and subscribe to AEL. Keep experimenting, and see you in the next video.